So by the end of this lesson, you should be able to graph transformations of the sine and cosine curve. The sine and the cosine function are very similar. They both form wave patterns. The sine function is the graph in yellow and the cosine function is the graph in blue. By analysing these two graphs, we can find some of their key properties. The first one, we know that these graphs go on forever in either direction. So we know that the domain for sine and cosine is minus infinity to infinity. The second one is the range. They both have the same range as the y values are all between -1 and 1. Where these graphs are different are their intercepts. The y-intercept for sine is 0, but the y-intercept for the cosine curve is -1. Both curves have several x-intercepts, but the values of these intercepts follow a pattern. The x-intercepts for sine are always found by multiplying an integer by pi. For example, 0, pi, 2 pi, -5 pi, 3762 pi are all intercepts for this function. For cosine, the x-intercepts are actually found by multiplying a number with pi over 2. For example, pi over 2, 3 pi over 2, 821 pi over 2 are all intercepts for the cosine function. When we look at the sine, the cosine, and the transformations of these two graphs, there are two things that we need to pay attention to. The first is the amplitude. The amplitude tells us how tall the graph is, and it's always measured from the x-axis. For example, here we have a sine curve. If we draw a line from the x-axis to the highest point of the curve, this is called the amplitude. So for this particular graph, we can see that our amplitude is actually 1. The next property that we need to look at is something called the frequency. Here are two graphs. What is the difference between the two? Let's focus on a specific area. We'll look at what happens between our graphs between 0 and 2 pi. Can you see that the difference is the number of times that the graph repeats itself? At the graph at the top, it repeats itself once, and at the graph at the bottom, it repeats itself 4 times. So we say that the graph at the bottom has a higher frequency, since 4 is bigger than 1. A transformation causes the shape of a graph to change by making it bigger or smaller, moving it up or down, or even moving it left or right. So let's see how we can transform our graphs. There are 4 transformations that we're going to look at in particular. The first one are vertical translations. So how do we move the graph up or down? The second is horizontal translations. So how do we move it left or right? The third is dilation. So how can we make the graph larger or smaller? And the last one is stretching. How can we make the graph wider or narrower? We've already seen a transformation of the sine curve without realizing it. The cosine curve is a transformation of the sine curve. In fact, it's a horizontal translation as it moves the sine curve to the left. In fact, every single transformation of the sine curve is called a sinusoid. A sinusoid has a general equation of y is equal to a sine bx plus c plus d. So let's see how changing the values of a, b, c, and d changes the way our graph looks.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
Let's see what happens to our sine graph when we decide to change the value of a. To see how changing the value of a transforms the sine curve, we need to be able to graph y is equal to sine x. We should already know these key values, and this is what the graph looks like. The value of a is 1 as there is no number in front of sine. The amplitude is also 1. Let's see what happens when we try to graph y is equal to 3 sine x. Use your calculator to find the values of y that we will need to plot. We get the values 0, 3, 0, minus 3, and 0. Can you notice a pattern with the numbers? Our values of y have been multiplied by 3. So our graph now looks like this. What do we notice about the amplitude for this graph? The amplitude is 3. This means that changing the number in front of sine causes the amplitude to change. So, in our general equation of a sinusoid, we take the absolute value of a to find the amplitude. To see how well you've understood this concept, here are some questions. Pause the video here in order to answer them, and once you've finished, play the video again so you can see the solutions. And here are your answers. Let's move on and see what happens to our sine graph when we change the value of b. In order to see what happens when we change the value of b, let's look at 2 different examples and see if you can spot a pattern. We know what sine x looks like, and it's important to note that the value of b is 1. What do you think happens to the curve when we try to graph y is equal to sine 2x? Use your calculators to find the values of y. Now, these coordinates may not give away as to what is happening, but let's look at the graph. Do you see a difference? Not quite yet? Okay, well, let's look at the 2 graphs together so you can compare the 2. Changing the value of b causes the frequency of the graph to change. It also changes something called the period. The period of a function is how long it takes to complete one cycle, so the amount of time it takes for it to go up and down. In the blue graph, the period is 2 pi. And in the red graph, the period is pi. There is again a formula that we can use to find the frequency or the period of a sinusoid if we are given the equation. Did you manage to notice how the period is the reciprocal of the frequency? This means if we know one, we can flip it to find the other. To see how well you've understood this concept, here are some questions. Pause the video here in order to answer them, and once you've finished, play the video again to see the solutions. And here are your answers. Let's see what happens to our sine curve when we start fiddling around with the value of c. Just like we did when we were looking at changing a and changing b, let's have a look at our original sine curve. The curve y is equal to sine x has 1 for the value of c, and we should all be very familiar with the graph by now. But let's see what happens to this graph when we try to plot y is equal to sine x minus pi. Take out your calculators and try to figure out the values of y. By comparing the coordinates, it looks like we've just multiplied the y values by -1. But let's have a look at the two graphs together so you can compare them and see if this is actually the case. What actually happens when we change the value of c is that we actually are moving the graph either to the left or to the right. In this case, it's caused our graph in orange to move to the right so that it looks like our graph in purple. Changing the value of c actually causes something called a phase shift. And there is a formula to calculate it, and it looks like this. To see how well you've understood this concept, here's some questions for you to try. Pause the video here in order to answer them, and once you've finished, play the video again in order to see the solutions. And here are your answers. We've seen what happens when we change the value of A, B, and C. It's time to see what happens when we change the value of D. Our original curve, sine x, has 0 for the value of D. And by now we should all be getting sick and tired of this graph and know exactly what it looks like. But what do you think happens to this graph when I try to plot y is equal to sine x plus 2. I'll give you a minute to get out your calculators and calculate the missing values of y. Right, let's compare the two values. What do we notice? Well, it seems like all I've done is taken the number 2 and added it to the number above. So let's see how this changes our graph. As you can see, our original graph, which is the one at the bottom in blue, has changed to look like the graph on top, the one in purple. And it's done this by moving up 2 units. This is called a vertical shift, and it allows us to look at something called the midline of a sinusoid. Imagine drawing a line that cuts the graph horizontally half into 2. This line is called the midline. And in fact, to find the midline and the vertical shift of a graph, we use the exact same formula. And in fact, it's always going to be the value of D. To see how well you've understood this concept, here are some questions for you to try. Pause the video here to complete them, and once you're ready, press play in order to see the solutions. And here are the answers. And just like that, we've come to the end of the lesson. So let's have a quick review of what we've learned so far. We can see that changing A changes the amplitude. Changing B changes the frequency and the period. Changing C changes the phase shift. And changing D changes the vertical shift and the midline of a sinusoid.